You know those giant, mysterious towers you always see standing outside factories? Ever driven by and wondered, what in the world are those things actually doing? Well, today we're going to pull back the curtain on these unsung heroes of the industrial world. We're going to dive into how they work and why they are so incredibly important for the air we all breathe.
The short answer? They're basically giving factory exhaust a bath, a really thorough cleaning. And in this explainer, we're going to break down exactly how this fascinating process helps protect the air we all share. Okay, so to really get why this solution is so cool, we first have to understand the problem it's trying to solve. And that all starts with the reality of modern manufacturing. Look, the bottom line is making all the stuff we rely on every day, our cars, our electronics, you name it, can get a little messy. Processes like painting or soldering circuit boards, they release exhaust gases and other pollutants that you really don't want just getting pumped straight into the atmosphere. And we're not talking about a small workshop here. We're talking about massive industrial sites like this one. I mean, these places are the backbone of our economy, but they've got this huge responsibility, right? How do you run a giant operation like this while also being a good neighbor to the environment? That is the core challenge. And that, my friends, brings us to our hero technology. Let's meet the machine that was designed specifically to solve this problem. Honestly, this is the absolute best way to think about it. Before any of that nasty gas has a chance to escape, it gets sent through what is, for all intents and purposes, a giant, super sophisticated washing machine. And here it is. This is the absorption tower. Its one and only job is to wash industrial exhaust, using a liquid solution to pull the pollutants right out of the air. So, how does that actually work? I mean, how do you literally wash the air? It sounds kind of strange, but it's a surprisingly clever process based on some pretty neat chemistry. It all really boils down to these 4 steps. You've got the contaminated gas going in, you've got a special cleaning liquid being sprayed down from the top. That liquid grabs onto the pollutants, and what comes out the other end? Clean air. Simple, right? Let's take a closer look. All right, this diagram gives us a peek under the hood. You can see the whole journey. The contaminated gas comes in through this port down at the bottom. Then it's forced up through all this stuff here, which is called packing material. Its job is to create a ton of surface area. At the same time, nozzles at the top create a constant shower of the absorbing liquid. So as the gas rises, it has to pass through this intense pollutant-grabbing rainstorm. Finally, right at the top, a demister pad catches any leftover liquid droplets before the clean gas is vented out. And the scientific principle making it all happen is called absorption. You've actually seen this a million times. It's the same thing that happens when you stir salt into a glass of water and watch it disappear. The salt doesn't actually vanish, right? It just dissolves into the water. In the tower, the pollutants are doing the same thing, dissolving into the liquid solution, effectively yanking them out of the air. And the scale of these things is just immense. I mean, look at these flow rates. A single tower for something like a painting line could be processing 15,000 cubic meters of air every single hour. For a big chemical plant, that can jump to over 26,000. That's an incredible volume of air being constantly scrubbed clean. So that's the theory. Now, let's see what these things actually look like out in the real world. Because they aren't just diagrams on a presentation. They're out there, right now, working hard across all kinds of industries. And this is so cool. You can see the whole life cycle here. On the left, you've got brand new towers loaded onto a truck ready for delivery. And on the right, you can see a crane carefully lifting one into its final position at a factory. They're designed to be transported and installed right where the pollution is being made. And they don't all look the same either. You might see a bright pink one or a dark green one. But this isn't just about aesthetics. The color and the material are chosen very carefully based on exactly what kind of nasty stuff they'll be treating. For instance, if a factory is dealing with some really corrosive chemicals, they'll use a tower made of a special kind of plastic, polypropylene, that can resist that harsh environment. For more general stuff, or for applications with really high temperatures, a tough coated steel tower is the way to go. It's all about matching the right tool to the job. Okay, let's just stop and think about this number for a second. Over 26,000 cubic meters per hour. To put that in perspective, that's enough air to fill about 10 Olympic-sized swimming pools every single hour, all cleaned by just one machine. It's incredible. So, what does this all add up to? When we zoom out and look at the big picture, why does this one piece of technology matter so much? Well, when you put it all together, you've got way more than just a piece of equipment. This is a durable, high-tech solution that helps industries meet really critical environmental standards.
It's a real-world example of engineering that helps us find that tricky but essential balance between industrial progress and the health of our planet.
So the next time you see one of these towers, you'll know exactly what it is. It's not just some random piece of industrial plumbing. It's a silent guardian, a crucial link in the chain, helping to keep our air clean while our industries keep on running.
This technology is amazing, but it definitely makes you wonder, right? As we get better at finding new kinds of pollutants, and as our environmental standards get even stricter, it raises a really interesting question for the future. What will the next generation of clean air technology even look like?